You need to stop using random splits. Welcome to my hallway. This is for the hallway track at NormConf. So, well, here's the thing. This is very loud. Random splits are a nice idea in statistics, but they don't really work in the real world. So I think the first thing we need is pens and better. So the problem with, random splitting your data is essentially that most of our data isn't randomly distributed. Like, have a look at weather forecasts, for example. Weather is always a time series. So we know the weather from yesterday, the day before. So really, how this looks is we have our usual graph right here. And then we have rain, and of course some kind of graph through this. Now if we were to just random split this and take one from here, take one from here, take one from here for our training data, and then let's do this in purple. We take this one and this one for our testing data. This gets super easy because this is just a linear interpolation. So we're almost correct just by taking the average of the two. We don't need a machine learning model for this. And like, this is a simple example, but if we have a look at something like maps, so like this, then we see if we have weather stations, like right over here, and another one, couple down here, maybe some in the middle, and of course in Seattle, and a couple down here, and we random split this one, then we might actually end up putting this one in our training set, and this one in our test set. The same might happen down here, putting this one in the test set and this one in our training set. Now, those are so close together that the weather and the weather patterns especially, are almost identical. So we are now not testing on an independent data set. We are testing on something that is extremely correlated. And that means we're getting much better results on this test set. And then what happens is you put all of this in production, or maybe you publish a nice paper on it, and someone tries to reproduce it on data from the next year, and it doesn't work. Or maybe it works, but it has much worse numbers than you had in your description, in your paper. And this is why we have to be really smart about splitting our data. So in the case of this map, we would split the map into quadrants, do cross-validation. So we use this one for testing and these three for training. And then we rotate this around so we can actually do some proper machine learning evaluation. And because we're rotating this around, we're not missing any locations. But this gets even more tricky. So if you look at people at companies like Uber Eats or Deliveroo in the UK, this isn't enough anymore, right? Because, well, in New York, you probably want a nice bagel, some $1 pizza, you know, the usual stuff. And then over in LA, you want your acai bowl and all that stuff. This doesn't necessarily translate. So we are now in this weird situation where we can't even split it like this, and it gets worse. So between LA and San Francisco, they are fairly close on like a national level, but they are different a little bit, right? So comparing those, even though they are so close together, gets really complicated. And then, there's breakfast, so you want some nice breakfast foods, maybe something from Starbucks, but when it gets later in the day, maybe you want Thai food. And so recommending to you what to order gets really tricky, because we now have a citywide split, and we do have, in addition to that, a time split in this. So it's spatio-temporal, and the spatial dimension is very, very fine. And what you can do here, because now we're talking recommender systems, of course, we can actually do an A-B split that is local and temporal. So essentially we're looking at the same week, and we're splitting it the next week, where we turn it on its head and hope that this gives us statistical, valid results. Because if we don't do this, well, then you end up in a hallway and, I don't know, give talks drawing on your wall. But no, seriously, like every real world data I have seen is either time, space, or spatio-temporally correlated, and you should look at your data, how you can find groups that have some kind of correlation that give you artificially better results. Because in a lot of cases, when you then put it into production, you can't rely on these easier results anymore, because this is fake, and the real test set in the end is your production data. Thank you. My landlord is gonna hate this.